Hello, everyone. Welcome to 4.2, the second section of Module 4 about matter. We'll be finishing Chapter 4 in this subsection. Okay, so some of the learning objectives for 4.2. Know the properties of protons, neutrons, and electrons. Know the meaning of atomic number and mass number and how to find the number of protons, neutrons, and electrons from this. Know how to find the atomic number from the periodic table. Know the meaning of ions and isotopes. Okay, so last time we talked a bit about atomic theory. So we talked about this idea that atoms are these tiny indestructible particles, and everything is made of atoms. Elements of different atoms are different, and atoms combine to form compounds and simple whole number ratios. We'll be looking a little bit now at kind of why what we mean by atoms in terms of the elements, and that, as it turns out, atoms are not the smallest thing. Before we get into this in too much detail, I wanted to talk a little bit about electricity. Lightning storms are some evidence we have that there is in fact charge present in matter. So what's happening in a lightning storm is you have a buildup of a negative charge and a buildup of a positive charge in different locations, and you have the charge flowing in order to equalize that, and it can be very destructive because there's a lot of energy associated with that. So the charge balance is disturbed, and the lightning is a way to get back to the typical charge balance. In general, for charged particles, we can say that if something has a positive charge, it would be attracted to something that has a negative charge, and like charges will repel each other. So positive repels positive, negative repels negative. If you have a positive and a negative, they cancel out. This is as much detail as we need to know about charge in order to understand what we will look at in this chapter. If you take a physics course, this is something you would get into in much more detail. So in about 1897, so actually not too long after Mendeleev discovered the periodic table, it was discovered that atoms had parts. Atoms were made of things instead of being the smallest thing. So this was discovered with experiments on cathode ray tubes. We'll look at a cathode ray tube in lab a bit later in the semester, but this is what they look like. And what was seen is that there was a particle in a cathode ray tube in it, and this particle was showing up in these tubes regardless of what metals were used. So there are metal electrodes here, and even when using different types of metal electrodes, the same particles showed up. Okay, so that's saying there must be something smaller than an atom. Here we're seeing that those particles had a charge. So we're showing a magnet. If we put a magnet near the tube, it will cause the particle to be deflected. So the particle has a charge, and is coming out of an element. Okay, so there is something smaller than an element, is what this is saying. There's something smaller than atoms. So atoms are what make up, the elements are made up of atoms, and now we're saying there's something that is smaller than an atom. Okay, so this is telling us that atoms have to be made of parts in some way. So this is one of the experiments that led to the discovery of the subatomic particles. We're not going to go through all of the rest, but just understand that through these experiments, it was realized that atoms are indeed made up of parts. So the parts we care about in chemistry are listed here. So the proton, the neutron, and the electron. So I want to talk a bit about some of the properties of each of these. The proton and the neutron are particles that are found in what we call the nucleus of an atom. Now, some of you might be familiar with the word nucleus from maybe your biology classes. It is not the same nucleus, but it is the same idea of having kind of a central part of a larger thing. So in an atom, we have a big empty space, And then inside of that space, there is a very tiny thing that's called the nucleus within that very large empty space. And then outside of the nucleus, in this mostly empty space, are the electrons. So there's a nucleus with most of the material condensed there, and then around that are electrons in the empty space outside of that. A couple of the properties of these, so in the nucleus, protons and neutrons, they are very massive. We have some numbers in this table from your book. Don't worry about memorizing these numbers. What you should know is that these two numbers for proton and neutron are much bigger than this number for electron. And that's true whether we're looking at the kilogram or the AMU. So protons and neutrons are more massive than electrons. They are also found in the nucleus. Also, we have a charge. So protons have a positive charge, neutrons have no charge, and electrons have a negative charge. So in terms of the properties of these parts of an atom, remember the charges for each of the three types of particles, and remember the relative masses. Okay, so we know that elements are exist as atoms, and from the periodic table we can learn some information about those atoms they are made up of. As it turns out, the number of protons is what defines an element. So if you change the number of protons, you have a different element. Most of the time, we will not be changing the number of protons. We can refer to this number of protons as the atomic number, and this number is found on the periodic table. So if we look at the periodic table, we see it. There's in each box represents an element. There are several numbers and some letters. So the number on the top is the atomic number. We use the letter Z to represent atomic number. The one or two letters that are kind of the most prominent within the box are the symbol of that particular chemical. And then we have something called the atomic mass. We'll talk later about what that is. And some versions of the periodic table will also include a name. Okay, I want to talk about, one other thing that can happen here. We've assumed so far that we have not had a charge. It is possible to have a charge for the elements themselves. So when an element loses electrons, it will have a positive charge. Because the electron has a negative charge, whatever's left is positive. So we're showing a reaction here. We're showing, okay, we have an element. That element loses an electron. Whatever's left has a positive charge. This is how we show that. We show the symbol of the element with a plus to indicate it has a positive charge. And we show that we lost the electron. So the charge of that thing that's left, so this is what we call a cation. If it has a positive charge, it's a cation. The charge of that is the difference between the protons and electrons. Okay, so number of protons minus the number of electrons. A neutral atom has these the same, so it would have zero charge. So for this particular example, we would have 3 protons and 2 electrons, so we would have a +1 charge. We can also have what's called an anion. So with an anion, we are gaining electrons. So here we're showing an example of that. We have the neutral atom, we're gaining an electron, we end up with an atom that has a negative charge. We do the same exact calculation here. The difference is that we'll end up with a negative number. So for this example, we have 9 protons. So we would find that from the periodic table. 10 electrons, so we have a -1 charge. Now the two examples we looked at, the lithium and the fluorine, weren't sort of accidental. There's a reason why they had the charges they do. Different regions of the periodic table will tend to have different charges. So we want to talk about that a little bit now, and it's something we'll get into more detail on in later chapters. So for now, you just want to be aware that in group 1, a +1 charge is common. Group 2 will have a +2 charge. Group 7A will have a -1 charge. Group 6A -2. Group 5A -3. Group 3A will be +3. So we can kind of see how that would make sense. So 1, 2, 3 this way, 1, 2, 3 that way. Again, we'll talk about this in more detail in a later chapter. Okay, when we change the number of electrons, we have different ions. When we change the number of neutrons, we have different, what we call isotopes. So here we're looking at a neon sign. Remember, the orange color means that it is neon. And if we zoom in and look at everything in there, we'll see that there are actually some differences in the neon. Now, they're all still neon because they all still have the same number of protons. But the difference, as we'll see, is the number of electrons. And so we'll see how we can keep track of that for isotopes. So we've already talked about the atomic number is the number of protons in the nucleus. This number is on the periodic table, so we can look it up for any element. The mass number is a number now that we'll introduce as we talk about this idea of isotopes. The mass number is the number of protons plus the number of neutrons. So these two added together. We can also think of it as the atomic number plus the number of neutrons. That would be saying the same thing. And isotopes are atoms of the same elements that are different based on the number of neutrons they have. So let's look at this table down here. And actually, before we do that, let's talk about how we can represent this information. So this is how we often show a particular isotope. So we have the symbol of the element. What we're showing here is an X, would be whatever the symbol is for that element. We have the mass number, and we have the atomic number. So mass number on top, atomic number on bottom. If you're not sure, the atomic number is always smaller than the mass number because it has to add up to make a larger number. In this table on the bottom, we're showing some examples of that, again, for neon. So there's actually two ways we can show the symbol. What we're showing here, where we have mass number on top, atomic number on the bottom, it would be one way. Or we can just show the symbol of the element followed by the mass number. We're not including the atomic number in this particular type of symbol because we can always look it up on the periodic table if we need to. The number of protons is the same as the atomic number. The number of neutrons is based on the mass number. So if the mass number is 20, we would say 20 minus 10 gives us 10 neutrons. If it's 21, we can see we would get 11, etc. by the same process. And then this last column is the percent natural abundance. We're not going to worry about that too much for this class. Just understand that naturally occurring elements will have a variety of possibilities here. Okay, so that is the end of module 4. Subsection 4.2 of module 4. If you have any questions about this, ask them on the discussion board. Go ahead and work on worksheet 4.2 related to that, and then proceed on to 4.3 when you are done.